Okay, so just here is a quick summarization of what you would need to know about parametric equations in calculus. So let's start with the basic. What we have is x as some function of time. X of t, let's call it. Y as some function of t, usually time. Let's call it y of t. So, if you take a derivative, you get dx dt and dy dt. If you take another derivative, you get d2x dt squared and d2y dt squared. And these give you three things. Your position vector, xy, your velocity vector, dx dt, dy dt, horizontal velocity, vertical velocity, how quickly you're moving left and right, how quickly you're moving up and down, and your acceleration vector, how quickly your velocity, horizontal velocity, is changing, or is it, and how quickly your vertical velocity is changing, or is it. So again, position, velocity, acceleration. Okay? We also know that speed is given by the square root of dx dt squared plus dy dt squared, for reasons that I explained in a previous video. We also know that distance traveled, aka in this case length of the curve, because the curve is what we're traveling, is given by the integral from t equals a to t equals b. I just put t equals a and t equals b there to remind ourselves that we're integrating over t values. Don't really need that, whatever. Of speed times a little bit of time. Well, that makes sense. If you're going different speeds for different amounts of times, you're going to take all your speeds, multiply them by time. So, well, speed times time is distance. So this is going to give you your total distance traveled, which is also the length of the curve. Let's see, what else? Well, if you want to find the slope of the curve, which is aka what direction are you heading, you just take the vertical velocity and divide by the horizontal velocity. If you want to find the concavity of the curve, which we rarely do, but sometimes we do, we take the derivative of our result up here, which is probably going to be a function of, it's going to be a function of time if we do this, and then we divide it again by dx dt. Okay, and those I sort of explained a bit in a previous video. One other thing I want to remind you of is if we integrate velocity, say from A to B, and we integrate our horizontal velocity, well, we should get the change in our horizontal position. So we have to be thinking again now about horizontal and vertical in everything we do. And this makes sense, right? dx dt times dt is pretty clearly dx, right? So rate of change of x times time. We add up a ton of little changes in x. That's what dx represents, and we get the total change in x. X of b minus x of a. The same thing would be true for vertical velocity. If we integrate vertical velocity, dy dt times dt, we should get the change in our y values. And this is the same thing as what we did before, really, with linear motion. It's just you've got a horizontal and a vertical. Note that this is change in position. This is not total horizontal distance traveled. This is not total vertical distance traveled. Nope, it's change in position. This gives you the total distance traveled counting for both. If for some reason you wanted total horizontal distance traveled, I guess you could do the integral from a to b of absolute value dx dt, dt, and and this would give you horizontal distance traveled. And similarly, for vertical, you could do a to b of absolute value, dy dt, and get total vertical distance traveled. Hopefully that's not off the screen. So this is pretty much everything you need. We need to be able to think, but besides that, you've got your position, velocity, acceleration vectors, you've got a formula for speed, you've got a formula for distance traveled, aka length of the curve, you've got slope and concavity, right, which is different now because these are horizontal vertical velocities, and this is slope, and this is acceleration vector, whereas this is concavity. And because we're moving along the curve, acceleration and concavity are no longer the same thing. So be careful there. And we also know how to get back to change in position from velocity, but in horizontal and vertical terms. Great!